Very good evening. Today I'm continuing the last part of the last day's lecture, that is the access modifiers in Java. In the last class I have discussed these things, but I haven't implemented these things in practical session. So today we are going to implement these access specifiers practically and want to show the accessibility of a data member or method or a constructor or a class to the others when we are using these access specifiers. So let me memorize once again what we have discussed in the last class. I mentioned Java has supports this four type of access specifier. One is public, private, protected, and default. And these four access specifier I mentioned in the column: private, protected, public, and no modifier. No modifier means I haven't given any access specifier. So that is called the no modifier, or better to say it's a default access specifier. Fine. And we are considering these 5 situations which may occur in the practical cases, that we are trying to access the data members or methods or constructors within same class, within same package and subclass. That means it's a child class and resides under same package. In the last class, we already discussed how we can create our own package and how we can use those packages. Third case that we consider, same package but non-subclass. Package is same, but that is not a child class. And another two situations are different package subclass and different package non-subclass. So these are the 5 situations where we discuss about this 4 access specifier. If we set the access specifier as public, that means it is accessible from same class, same package subclass, same package non-subclass, other package subclass, other package non-subclass. All the cases are yes. It means we can access the members which set as public from anywhere in the program. All 5 cases it is yes. Just the opposite scenario in case of private. It is only accessible from its own class. If the data member is set as private, you can access that data member only from its own class. Rest all the cases it is just no. Look at the first column. It is for the same class only yes, and rest all data members are no. Rest all the cases are no. If you use the protected access specifier, that means you can access the data members same class yes, same package subclass yes, same package non-subclass yes, other package subclass yes, other package non-subclass it is no. So in case of protected access specifier, the data member cannot be accessed in other package and non-subclass. Other package subclass, it can be accessible. But if it is a non-subclass, that means it's not a child class, so we can't access. That is the protected case. And what about no modifier? That means the default access specifier. The default access specifier says we can access the data member from its own class, other package subclass, sorry, same package subclass, yes. Same package subclass, non-subclass, yes. Other package subclass, that is no, and other package non-subclass, that is also no. So when we are trying to access the data members from other packages, we cannot access if the data members access specifier is default. So this is the difference. I already mentioned this in the last class, that this is the difference between an public access specifier and default access specifier. Default means if I mentioned no access specifier for a data member or class or a constructor, then I can consider that is the default access specifier. So this is the difference between a public access specifier and default access specifier. In case of public access specifier, it is accessible from anywhere. Rather in the other package, we have seen that other package subclass, other package non-subclass, it is yes. Accessibility is yes. And when I'm talking about the default access specifier, it is accessible only my own package. That is where it is defined. Own package, subclass, own package, non-subclass, yes, it's true. But other package subclass, other package non-subclass, it is no, it is false. That means we can't access that particular data member or class or method that I set as default access specifier. So this is the difference between public and default access specifier. Now we try to implement all those access specifier in a single program. That program I have considered from Herbert Shield. I have implemented the same program just in machine. Try to understand. This is entire program is given in the Herbert Shield. Just a minute. Just a minute. No, this one is not. Yes, this one. Look, I'm talking about a package. The name of the package is P1. Let me introduce the package P1 and P2. Then I am coming back to the example. Look, what is the location of this P1? First, try to understand. D drive. D drive, I have created a folder PKG. Under PKG, I have this too. Let me share once again. D drive, under D drive PKG, we have P1 and P2. Try to understand. We have P1 and we have PA2. And today, the programs that we are going to discuss, basically they are in P1, some of them are in P1 and some of them are in P2. That I will mention while we discuss the program. So P1 and P2 is nothing but two packages. Both are in D drive PKG, because yes, in the last class, I already shown you that I have set this dpkg in the environmental variables class path so that it can be easily found when the program executes, when the program runs. Fine. Coming back to the program. This is the first program of the P1. It is when I include some class under a particular package. What is the first line that I mentioned? Package name. So this class protection, I want to include under package P1. Try to understand. This class protection, I want to include under package P1. So that's why I have written package P1. What I have done here, I have considered 4 variables. One is n, all 4 are integers, and another one is n pri, another one is n pro, another one is n pub. Hopefully you can understand what is the meaning of this 4. And I have given the access specifier according to the variable name. N prime means n is the variable which I consider access specifier private. All 4 are integer. I have set the value for n, n prime, n pro, n pub, all 1, 2, 3, 4. For the first one, it is default. For the second one, it is private. That's why I have taken the variable name just like this, n prime. Third one is protected, n pro. Fourth one is public. That's why I have taken n pub. And this is my constructor considered as public. Public means it is accessible from anywhere, all the 5 cases. What are the 5 cases? Same class, same package subclass, same package non-subclass, other package subclass, other package non-subclass. All 5 cases is yes. What about private? Only accessible from own class. Rest all 4 cases is no. What about default? Only same package, it is yes. Same class, same package subclass, yes. Same package non-subclass, yes. But other package, both these 2 cases is no. Other package subclass, other package non-subclass, it is no. What about protected access specifier? Protected access specifier, it is accessible only up to other package subclass. Other package non-subclass, it is no. So same class, yes. Same package subclass, yes. Same package non-subclass, yes. Other package subclass, yes. But other package non-subclass, it is no. So try to understand, try to remember this chart so that we are going to implement this chart in program. Fine. So this is the first program that I have written under package P1. And according to the table, according to the chart, this all 4 members, whether it is private, whether it is protected, whether it is default, whether it is public, it is accessible from own class. So because I have trying to access these members in the own class, the name of the class is protection. So that's why all 4 can be printed over here. It definitely gives the output. Fine. Second program. That second program, the name of the program is derived.java. The second program is also accessible, also under package P1. Second program also under package P1. But try to understand, this is basically a derived class. This is basically a derived class. Derived class of protection. The protection just we discussed. This is a derived class. So class derived extend protection. This class also in the P1. So what it means? Same package subclass. Same package subclass, because it is P1, same package. If we compare with the previous one is only same class. Second program is same package subclass. same package, subclass. So it is basically P1, class P1, package P1, that means same package, but it's a subclass of derived class. Fine. So try to remember the chart once again. Public, yes, true. Private, no. Only it is accessible from own class. So private member you cannot access from here. What about default? Yes, it can be accessed. What about protected? Yes, that can also be accessed. So look, I have commented this line, private and pri, because private member can only be accessed from its own class. Understood? Third program, that is also the member of package P1. That is also the member of package P1. It is same package, but non-subclass. So same package, non-subclass. Package P1, same package, non-subclass. Same here. Rather, if we compare the last one, same here. What I have done, I have created an object of protection class. Protection is my first class that I discussed. I have created an object of the protection class as, your one question may arise in your mind, how this program, this same package class can get this protection class, because protection class is defined under package P1. The same package class that we are going to define, it also under package P1. Fine. So no need to import P1. No need to write this, because both are under package 1. But one thing you must remember, before compile this program, same package, before compile this program, same package, or derived.java program, same package.java program or derived.java program, you must have to compile protection.java program. Why? Because this protection.java program, when you compile, this will generate a class file. Name of the class file is protection. And this protection class is used here and here. So before compilation of these two programs, you must have to compile protection.java, and no need to import this protection class over here, because all are under package P1. So this program is also under package P1. What you have done, you have created an object of protection class. You have created an object of protection class. So when you are going to create an object of protection class, now P try to access those data members which are declared under protection class. 4 data members is there: private, protected, N, Npri, Npro, and Npub. Look, P.N, P.Npro, P.Npub, and P.Npri that I have commented, because same package, non-subclass, private cases no, because we know the private data member can only be accessed from where? From own class itself. When we are coming out from our own class, it cannot be accessed from anywhere. So hopefully this much is clear. No, I will come back this demo.java, right? Demo.java is actually consisting our main program for package P1. So that's why this demo.java is also under package P1. So no need to import anyone, because all are inside package P1, and we have compiled all those 3 files. That's why class file created. What I have done under demo.java, we have created an object of OB1. We have created an object of protection class, OB1 of protection class. we have created an object of OB2, object name OB2 of derived class, and we have created an object OB3, which is coming from same package class. Look, same package constructor defined, derived constructor defined, and protection constructor defined. So automatically when I call this constructor, this gets executed. When I call this constructor, this get derived constructor, this gets executed. When I call same package constructor, this gets executed. So I will execute the program later on. Try to understand first. Second case, that is package P2. Package P1 is over. Now I'm coming to the topic package P2. What package P2? It consists, so I have to demonstrate two cases. Try to remember the chart. One is other package subclass with respect to P1. We are going to define P2. P2 is the other package. So other package subclass and other package non-subclass. So it's nothing but the other package subclass. Why it is other package subclass? I'm going to define a class protection 2. I'm going to define a class protection 2 which extends protection class of package P1. So that thing I have to write in this manner. P1.protection. It means I am trying to access the protection class which is under package P1. So this is actually my other package subclass case. So what I am doing here, again I have to write a protection 2 constructor. Try to remember the chart once again. Other package subclass for the public. For public, yes, it is true. For private, false. For default access specifier, false. Protected, true. So public and protected are true, is accessible, but private and default is not accessible from here. So that's why I have commented these two cases, private as well as this default. Because default is accessible, default member is accessible only up to own package. Other package subclass, other package non-subclass, both these two cases, the default cannot be accessible. Hopefully this much is clear. Next, another program that I'm going to discuss that is also under package P2. That is also under package P2, and for the consideration of the cases, which case? Only one case left, that is other package non-subclass. So we are going to define a class which is other package, but which is not extending from any classes of the P1. So that's why it is other package non-subclass. Fine. Other package non-subclass. So I'm going to create an object, other package constructor. Inside other package constructor, I'm going to create an object P1.protection. That means I'm trying to access the protection class of the P1 package. The name of the object I have given P, new P1 protection. Remember the chart once again. Public accessibility is yes. What about private? No. What about default? No. What about protected? No. Because protected data member can accessible from up to, not from, up to other package subclass. If the data member or class or constructor, whatever, is set as a access specifier protected, it is accessible up to other package subclass. It is not accessible from other package non-subclass. So that the example that I considering now is nothing but a other package non-subclass. Fine. Understood? So that's why all three cases I make it commented. Only public data member gets printed. Fine. No issue. Then this is the demo.java program. It is basically consisting my main method for package 2. Earlier I discussed another demo.java program which is under package P1. Fine. But this demo.java is consists under package P2. Fine. So thing is that what I'm doing over here, two classes I have considered in package P2. One is protection 2, another one is other package, right? I have created these two object of these two classes. One object that is OB1 of protection 2, another object of OB2 that is other package. So hopefully you understood the meaning of these programs. Again, I am briefing the matter. I have considered two packages, that is P1 and P2. Under P1, we have protection.java, derived.java, same package.java, and demo.java. Demo.java is nothing but our main program for package P1. Because I try to execute these three Java programs, whether Java classes. After compilation, we will get the class files of these three classes. One is protection.class, another one is derived.class, another one is same package.class. Fine. And I have considered one more packages, that is P2, where I have defined two Java programs, written two Java programs. One is protection2.java, which is basically a child class of P1.protection. P1.protection means P1 is my package, and .protection means protection is the class that is defined under package P1. And the other package, which is basically a non-child, is not a derived class of package P1. So other package subclass, other package non-subclass. And also defined one more main under package P2. Under package P2, that's why I have written package P2. So we have created then to execute basically these two class files. One is protection2.class, another one is other package.class. Fine. So what to do next? Next, we have to compile all these files. So protection.java first, then derived.java, then same package.java, then demo.java. Compile. And when you compile, you just enter into the package by in the command prompt. If you do this, just write cd ... Just enter into the package, enter into the folder P1, and the compile all those files. And coming out P1, enter into P2, compile this protection2.java, other package.java, and then compile demo.java. You have to follow the order. First, you have to compile protection.java. Because why? I already mentioned that you have created a class file, you have created another class that is derived, which is coming from protection. Similarly, in protection2.java, you have define another class, which name of the class is protection2, which is also derived from protection class under P1. So you need to compile protection.java first, because this will, if you not compile this file, if the class file is not ready for this protection class, then when you try to compile this first derived or rather protection2.java, class not found error you will get, because this two programs is not getting the class files defined over here, that is protection. So follow the order of compilation. This is important. So after compilation, what to do? You have to execute the program. So I have already compiled that. That's why I'm not showing that part. I've already compiled. Just I'm showing you the compiled files. Look, under P1, under P1, we got this protection.class file. Fine. Derived.same package.class file, derived.class file, as well as the demo.class file, because I have already compiled. And for package P2, I have two Java programs. So we have two class files after compilation. Sorry, three Java programs, including demo. One is protection2.class, another one is other package.class. And we got the demo.class file because I have compiled the demo.java program. Fine. Now we are going to execute the program. So I have to first reach where? It's in a D drive, right? It's under package. We have to execute that two demo files, rather demo.java program, better to say. I have to execute that demo.java program. So one demo is under P1, another demo is under P2. My question is, shall I enter into P1 when I'm going to execute demo under P1? What is the answer? Is it yes or no? Definitely the answer is no. Why? Because when I am entering into package P1 and I am trying to execute standing under package P1, so try to remember the line of code. Class derived extends protection. So where it is under package P1. So all files under package P1 and all class files are interrelated somehow. Derived.java is interrelated with protection.java. And you are accessing all those class files from where? Demo.java, rather demo.class files. So because all are the programs under package P1 and only demo class under package P1 can be executed because it consists the main method. All other classes you cannot execute because they don't have any main method or any static methods. So you have to execute that demo.class files. When you compile, you may enter into P1, you compile it, no issue. But when you execute the program, you must have to execute from just outside of package P1. So definitely next question, how we can execute by standing outside of package P1. Look, that is the case that I must show. I have to write Java. Here I have to write Java P1, that is my package name, dot demo, that is my class file. Demo.java I have compiled, I got the demo.class files, and p1.demo means I try to execute demo class under package p1. What is the output? Look, output comes. I'm going to explain the output. What is the first line of demo.java under package p1? Try to understand. Created an object of protection class. So all four will come. What is the second line? Derived class. Created an object of derived class. Go to the derived constructor. This is the derived constructor. What is the rule of multi-level? This is basically a single level inheritance. Multi-level inheritance, single level inheritance. What is the rule of the constructor calling? We know child class must call the parent class constructor. Only the default cases. Means the non-parameterized constructor. So which one is the child in this case? It is derived. And which is in the parent in this case? It is protection. So when derived constructor is being called, it must call the constructor protection again. So this set of output will come again. One, it will come for call protection. So the second call derived, it will give you this set of output once again, because parent class constructor will be invoked, because the rule of parent class constructor invoking, and this three line also comes into the output. Fine. That is the output of second line. What is the output of third line? Which is same package. The output of the third line, as because this is no question of child class, definitely it will give you only this three output. Three line. Coming back to the output screen. Look, this is for the first call, base constructor, all four gets printed. For the second call, base constructor part gets printed. This is coming from the derived. Fine. This is coming from the derived. Fine. What about the third part? How it is coming? Let me check. It is the same package. What the same package says? Look. Oh, sorry. Same package under same package, what we have done? We have again called the protection constructor. So that's why there's this set of output again come. And after this set of output, it will give this three line. So coming back again to the output screen. Sorry. No. Yes. For the third line, this set of output comes again. Is because I am calling the constructor protection. And after printing this is the output of the same package constructor. So first output base constructor, second output base constructor will be called, then derived constructor, then For the third line, first it calls the base constructor protection object. When we have created the protection class object, definitely it will give this, and this is the same package constructor. So hopefully the output is clear to you. So this, for the same package, we discussed all 4 access specifiers regarding public, private, protected, and default. Next, I am moving to the next package, that is P2. What we have done over there, 2 cases earlier mentioned. One is other package subclass, another one is other package non-subclass. So this case is other package subclass. So I have called P1.protection. Protection 2 extends P1.protection. So definitely again, it will call what? The parent class constructor. So this 4 will come into the output. For this 4 will come into the output when protection 2 is being called from demo.java under package P2. This demo.java under package P2. So protection 2 gets called. Protection 2, you have created an object OB1 from protection 2 class. So when protection 2 gets called, so definitely it will call the parent class constructor, which is the parent class constructor in this case, protection class of package P1. That is the parent class of protection 2. So that's why again this constructor will be invoked, and definitely base constructor and this 4 will come into the output stream. Then for other package constructor, protection 2, then this 2 will come into the output. One is derived other package constructor, one is protected, another one is public. Fine. What about the second line of this demo.java under package P2? This will give you other package OB2, new other package. So you are going to create an object of OB2, other package. So other package constructor, what you are doing under other package constructor, you have created an object of again P1.protection. So definitely this set of output you will get once again. Base constructor, this set of output you will get once again, and then the rest of the lines of this constructor. What is the rest of the lines? Only the public gets printed, because all other 3 are not accessible here. That I already explained. Showing you the output. Again, the same manner, we will execute the program, that is Java P2.demo. That means we are trying to execute the demo class that is under P2, package P2. Look, let me share. Yes. Look, here from here I have trying to execute this Java P2.demo. So first line is basically I'm creating an object of P1.protection class. It is extending from P1.protection class. So that's why base class constructor will be invoked, and that's why you are getting this 4. And the next line will give you this 2 only, n protected and n public, because only protected member and public member, public protected access specifier and public access specifier is accessible from other package subclass, rest are non-accessible. And for the second line of the demo in P2, that is other package non-subclass, what you have done, you have created an object of P1.protection class. So that's why protection constructor of P1 gets invoked, and that will give you this 4 lines, rather 5 lines, base constructor and output of these 4 data members. And in the other package constructor, other package subclass, sorry, it's a case of other package non-subclass. So in other package non-subclass, according to the chart, what we know only public can be accessible, public data member can be accessible. All other cases, whether it is private, whether it is protected, whether it is default, all other cases, it is just no, it cannot be accessed. So that's why only public member is giving the output, that is for npub. Npub means n is the variable which is declared as a public access specifier. So hopefully this, you understood the output of this program, and through this program we are basically going to explain the accessibility of the data members as well as class constructors when we give different type of access specifier on them. 4 access specifiers are in Java: public, private, protected, default. Thank you. Thanks for your patience.